Hello guys. Can you hear me? I have to check just a minute. I'll just check it. Give me like 1 minute. Home. Home. Okay, yeah. Thing is working, so I'll just close it. Yeah. Let's just don't mind it. Okay, let's do it. Um, yeah, I just changed everything, dude, like the browser and everything. Okay. So let's. Oh, okay. Um. So yeah, let's just start from the search in 2D matrix, okay? Um, I'll just open it up anyways. So yeah, I've already tried to do this. I don't think it's working, but I'm not sure. Okay, this is so what we're doing here exactly. Okay, login. Everything is gone, dude. After changing the browsers. Just a minute. This is for my API shit. I was trying for Google APIs. Google products, developer tools. So I was needing a mail for that, so that's why I created that. Okay. Mm, so yeah. Mm, just a minute. I'll just 1 minute. Okay. I'll just briefly explain what I did here. Yeah. Actually, yeah. I forgot to tell you. Actually, I've done few questions which were not streamed. Okay. I think yeah. So yeah. I'll just explain this. 1 minute, I'll just Windows Control T. Yeah, I'll just put this over here, this over here. Okay. Okay. So yeah, guys. So you know binary search, right? In a sorted array, how we use binary search. We just split the array by two, and we check if it's right or left. The same concept. So I've done the binary search in a separate function, and binary search takes an array and a target. If the element exists, it returns true. If not, it returns false. Okay, this is a basic binary search. Uh, question was wrong. A coding question was wrong in my TCS for somehow. Okay. So yeah, so what okay, I didn't even complete this. So this seems like hmm. Yeah, I have the for loop started, but I have not corrected it, I think. Okay. Aptitude part only. Aptitude. Okay. Mm, damn, bro. 3 days rain. Okay. Cooling over the next 3 days. Okay. Got it. Studying now. Okay. Okay, guys. So top fans. Oh. Okay. நான் படிக்கிறேன். சைலண்டா இரு. So yeah, guys. Okay. Okay, okay. Let's just focus on solving this problem. Yeah. So yeah. So m is the length of the row, and n is the column. Okay. So we are iterating through rows, and each row we are taking the array and putting in a binary search. Right. Mm, yeah, this is my solution, but this is not the most optimal solution. But I'll try to do this. Okay. Yeah, we don't even need to iterate. Okay, let's just let it be there. Okay, we are iterating through each row in the matrix. Mm, yeah, okay. So I plus plus. So we're taking the array I. I is the array right now. So we are searching it with binary search. So return binary search of array, which is I, comma target. No, we can't do this because in that particular array, if the element is not there, it will return false. But we don't. Uh, Okay, got it, got it. Okay, if condition, if mm, okay, I is equal to m minus 1. Yeah, that is correct. If I use m minus 1, then we return the binary search I comma target. Yeah, so this is not I, this will be matrix of I. Matrix of I. Matrix of I, okay. Okay. So if this is true, then return it. If not, else we just see we just return this value. Okay, value exists. Let's say boolean value exists equal to, okay. If value exists, then we just return uh, exists. It shouldn't be capital. So this is okay. So what's happening? So we'll just to do a dry run in our head. So what's happening is we are taking this, which we are taking only rows here, columns are not needed here. Okay, so because everything is sorted over here, so let's take a for in this for loop. We're taking the rows, we're iterating through each row, and each row is I. So if I, so I is not each row, I is the index of the each row. So each index of the row in the matrix. So if I is equal to m minus 1, which is the last row in the matrix, then we return if the binary search of the last row is false, means it's not there in the entire matrix, because we're iterating through each one of it, right? So else, if not, if it's in some other row, then we take the result. If it's true, then we return the value. If it's not true, then we just don't care, we just continue it. Okay, so this technically should work. I don't know. Oh shit, oh my god, okay, I just noticed it. A second. It's been a while, it's been a while. Give me some time. I think I don't know if the binary search is true. Huh? Matrix dot length. What happened? I don't know, something happened. So matrix, so the columns are, we don't even need this, dude. I just not, yeah, don't even need this. So yeah. If the binary search is right, then it should work. Time limit exceeded. Okay, got it. Then it might be true, yeah. This is probably working, but we can't test it just because the time limit is not, time limit is exceeding. Okay, got it, got it, got it. Okay. Mm-hmm. So what's the better way of doing this? So instead of iterating through each and every array, each and every row, uh, can you just take the first and last element of the matrix and sorry, first and last element of the row, and based on the first and last element, we don't even have to put it through the binary search, and then we can uh, uh, directly use the binary search only if the element is present inside the array, which is, yeah, that should work. So yeah, so how do I do it? So now I need the columns. Okay, the matrix of 0 dot length is the columns, number of columns, and matrix dot length is the rows. Okay, got it. So yeah, okay, so we can just take it off. Okay, so we have to iterate. Do we? Yeah, we need to iterate. So I is the row, and we have to check the first and last element. So if matrix of I of 0 is lesser than the target, so then equal to also is true. Okay, so equal to the target, and and matrix of I. So what's the last length? N, right? Yeah, n minus 1 should be right. Is greater than or equal to target, which is, so it lies, yeah, it lies in between. If it lies between, then we do the binary search. So binary, so return binary search of matrix of I, comma target. Okay, so if that is true, then we check it. If not, just return false. This is straight up. Okay, wrong answer. Okay, so what's the problem? I don't know if the binary search is right. Let me check it once. 1 minute. So output is true, expected is true. Output is true, expected is false. Okay, so output is coming as true for the binary search. So what's the problem? So yeah, target is 13. So target is 13, which lies in between. Yeah, this one, the second array. So what will happen? 10 to 11, 16, 20. So the 10, 11, 16, 20 array is put into the binary search. Yeah, okay. So low is array of 0, so which is 10. High is array dot length minus 1, which is 20. Um, yeah, mid is high by 2, which is no, 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 no. Oh, okay. Wait. 1 minute. Should we shouldn't take the, we take 0 only, right? I shouldn't take the values, I think. Yeah, that is the issue, I think. Just a minute. I think so. I'm not sure. Yeah, yeah. Array of length minus 1, which is the high index, which is the last element index, and mid is high by 2, which is yeah, integer of high by 2, which is, so yeah, we'll take it. So we'll take 0, low is 0, and 20, and high by 2 is 11. So yeah, 1. So 0, 1, and 3 is the value. So 0, 0, 1, and 3. Okay. So while low is lesser than high. Now, yes, should we do array of low? No. I think this should be exactly as it is. So low is less than high, which is not true in this case. If target is lesser than mid, so yeah, mid will be array of mid. So yeah, if target is lesser than uh, array of mid, which is not true in this case. 13 is not lesser than 11. Else if target is greater than or equal greater than array of mid. So if it's greater, is it greater? Yes, it is greater because it's 11 and it is greater. So low is equal to mid. So low is equal to mid in this sense. So what will happen? 10 will become 1. So 0 will become 1. So okay, so mid is equal to, again, what will happen? Mid is equal to, we are again calculating the mid. So which is low plus high, which is 1 plus 3 by 2, which is 4 by 2 is 2. Yeah, correct. 4 by 2 is 2, which is 16 here. So 16 is the mid here again. High didn't change. So again we are looping. Low is not equal to high. Yes. Again low is not equal to high. So if target is lesser than array of mid, maybe this works, man. I think it should work. I don't know. Should I go through everything one by one? Time limit exceeded. Why? Is there any error here? Let me just check it, guys. 1 minute. Hello? Ah? Ah, okay. There's a corrected version. Okay. Move the calculation of mid inside the loop to ensure it updates correctly in each iteration. So what have they changed? Oh, mid is only calculated once at the beginning. Yeah, that is okay. Exclude the case where low is equal to high. Oh, okay. High is equal to mid can cause input when low is equal to mid. Oh, we are moving the pointer. What? Those equal to mid plus 1. Okay. Why mid plus 1 though? Ah, ah, ah. So you're moving the pointer one by one like this, side to side. Okay, got it. I think I got it. Next time I'll implement it correctly. Let's see if it works. Yep, it works. Let's submit the code. But I don't know if this is the most optimal solution. Let's. Oh, damn. But let's see if this is the most optimal solution. Okay.
Okay, so let's
Just give me 1 minute. Nah. கூப்பிட்டுட்டு Yep, I'm back.
continue with our binary search playlist. Minus 1, because that is the one of the ways is go is smaller than equal to the last one, which is array of I. M minus 1 is the last index. If that's the case,
Oh,
maybe I can do a binary search.
Okay.
Maybe I can do a binary search. And I'll be like, return binary search. You know how to do a binary search on a 1D array. Return binary search. What is your 1D array? Your 1D array is array of I. If you do array of I, this is like, sorry, matrix of.
So basically, this entire thing is an algorithm for a 2D binary search. Okay, got it. I think I
I
got it.
rather. If you just do matrix of I, my bad, matrix of I, it'll be matrix everywhere. What do you mean by matrix of I? It doesn't mean the entire one. Matrix of 2 will mean this array. When you say matrix of 2, it actually means a 1D array. If you say like 2 dimensions, it means a 2D array. So you're just picking up this one. You're sending this and you're asking the binary search function to check if the target is there or not. And you know how to write a binary search function. Whatever it returns, if it finds, it will return you a true.
So,
if it doesn't finds, it will return you a false.
there are
And depending
more
on that, you do the
optimizations,
return statement and the if will time. You'll do M elements, the time. That's it. Still as good as big of n, but I can still optimize. So the previous complexity was as good as big of n. How can I optimize that? If you carefully notice, the entire array, rather the entire matrix, is sorted in itself. If I hypothetically, not in the real world, hypothetically try to flatten this matrix, flatten a 2D into a 1D array. Hypothetically again, flatten a 2D into 1D. I'll just do it in my brains.
Okay,
Will it look something like this? 3, 4, 7, 9, 12, 13, 16, 18, 20, 21, 23, 29. Yes, it does look like that. What will be the size of this? Can I say the size of this will be n cross m? The size of this will be n cross m. And it looks like a 1D array. It looks like a 1D array. And it is sorted. I need to look for target.
Can you explain binary search? Yeah, dude. So yeah, so binary search. I'll put it in very simple terms as much I can. Okay, as much as I can. Um. So yeah. So binary search. So there is. So binary is two, right? So we are checking the two different parts of an array. Okay. So let's take an array, for example. Let's take a 1D array. Okay, one-dimensional array, and we have sorted elements, so everything should be sorted. If it's not sorted, we can't do binary search. Okay, so it should be sorted. If not sorted, we have to sort it. So in this case, we have a sorted array. Okay, so we take the sorted array, we declare a low and a high. So the lowest point in the array and the highest point in the array, and a mid. Okay, so first we don't have any mid. As we go into the door mode, door mode. Yeah, hello, sorry. Um, yeah, if you're there, I'll continue the bunny research. My bad, sorry. Yeah, so, yeah, yeah, I'm back. I'm back. Uh, so we have an array. So as I said, we take a lowest point in the array and the highest point in the array. So which basically means the zeroth index and the last index of the array. Okay. So that is the low and the highest point. So that's what we're doing here. Okay. And here we are saying until low is lesser than high, which is the lowest point is lesser than the highest point, the index which we are taking, low and high, it shouldn't cross. If it crosses, then we stop the loop. Okay, that's the while loop declares. Okay, so that's how we declare a while loop in this condition. So so yeah, so in this we take int mid is equal to low plus high minus one, high minus low. Here so this calculation is not very hard, not very hard to understand. This is, see, every time we change the low. So for example, if the low is 0 and the high is some 4 example, uh, what will be the mid of the array? Okay, what will be the mid? So if it's 0 and 4, it will definitely be 0 plus 4 by 2, right? 0 plus 4 by 2 is 2, so 2 will be the mid. So here what they're doing, see here, so here low plus high minus low. Okay, yeah, so low plus high minus low. Here, here this is not necessarily, you don't have to do it like this, but I think this is some uh I don't know, man. I think to optimize it based on some conditions, I don't know, but this is not required. So whatever I said, which is also good. So low plus high by 2, that is more than enough. So I just took it from ChatGPT, this binary search. So that's why this has given a different code. See, for example, low plus high minus low, high minus low, right? So you don't have to do this. You just have directly can do high plus high plus low by 2. That is also fine. So here, so once we calculate the mid, so mid of the array, we took the mid of the array, we have the low and we have the high, we have all the 3 points. So now we check the conditions. So we take mid. Mid element is the important part in the binary search. Okay, so array of mid is equal to target. If the mid element is the target, we directly return the true. Okay, so we know that the mid element, if we know the mid element is the target, we can directly return it's true, right? So we don't even have to check the other things. So if it's not true, then we check if the value, if the target high minus low to segregate. Yeah, I think so. Yeah, I think so. Because see here, high minus low by 2 is a separate function, and plus low is a separate function. So I think they are just doing it for better mathematical calculation. I don't know. I think so. I have to check why this is. Thank you for asking. I'll just check it later. Okay. So yeah, so if there is like a mid, okay, and if the mid is a target, then we directly return. And if it's not, we have to check. This is a sorted array. Just remember, this is sorted array. And if this sorted array has the element, the target after the mid, which means the right side of the mid, then we have a function, then we have a if statement for that. If it's in the left side of the mid, then we have a if statement for that. So that's what we are doing here. So else if and else. So first else if, what we are doing, we are checking if the target is greater than the mid. So on the right side, if it's on the right side, you have a intuition of where the low and where the mid is, right? So if it's greater than the mid, so what we are doing, we are just change we don't have to calculate the left part anymore. So we just completely have to dissolve this. We don't even need this. So what we do, we just take this low from the left, from the 0th index, we put this near the mid. Now we know the mid is not a target, so we don't have to check the mid again. So what we're doing, we're taking the low part, which is the 0th index, we are putting it after the mid. Okay, so we have to check the this part now. So the low is now here, the high is here, and the mid again we should calculate. So what is the mid again? So mid again will be low plus high by 2. That's so again the mid will be over here. Okay, so we got the mid again we got the mid. So you find the iteration, right? So again we got the mid, again we have low, again we have high. Again we are checking if the value is in the mid, if the target is in the mid, then we return true. If it's lesser than the mid, then we again do this. So if it's lesser than the mid, we don't need the right part, so we have to change the high to the mid, and just get the small thing, right? So you find the uh, find how it works. So if you don't understand, just let me know. I'll try to explain what's happening, where it's happening. I think it'll be better if I just open Paint and explain. I just totally forgot that Paint existed for some reason. Let me know if you didn't understand it. Yeah, I'll just put an array like this and then explain. Understood, okay. If you didn't understand, let me know. Okay. I'm not a professional, dude. I'm just a beginner. I'm just trying to learn how everything works. I still didn't get a job, so I'm trying to get a job. So I'm trying to focus. So yeah, let me continue this YouTube. Yeah.
So if I look for target in a 1D sorted array, what is the time complexity? I just need to apply binary search, and the time complexity will be big of
Log n. Okay.
logarithmic of the size of the array, and the size of the array is n cross m. So if I can...
I was looking LSA on YouTube and found your channel. Damn. Is my channel that... oh, okay. I didn't know it was coming in search results, dude.
Flatten a 2D into 1D, not in the real world, in my brain, just hypothetically. If I can do that in my imagination, if I can reduce some formula and do that, I can actually search in a 1D array in a time complexity of big O of logarithmic n cross m. Now, if you go ahead, if you go and flatten it into an original 1D array, that will be of no use, because in order to flatten every element, you will end up taking big O of n cross m, because you'll go through every element, you'll put it into a 1D array, that will end up taking a lot of time. So technically, you cannot flatten it in real world, because if you try flattening it, the flattening process will take n cross m. So you should not flatten it. Just think it in your brain, how can you flatten it? So let's look at this. Can I say one thing? This index is 0, and over here n is 3, m is 4, so n cross m, the total number of elements is 12. Thereby the last index will be 11. Yeah. So what you will do is, you will perform a binary search where low is 0 and high is 11, and you'll find at the middle to be 0 plus 11 by 2, that is 5. See? So the value of middle is 5. If you would have converted it into a 1D array, you can easily see that the value at the 5th index is 13. But you actually don't have this 1D array. You don't have it. It's a hypothetical array that you're thinking in the back of your mind. What you have is a 2D matrix. And 0, 1, 2, 3, 4, 5. At the 5th index, you have 13. So somehow, somehow, if you can figure out that this is the fifth index, which is 0, which is 0, 1, 0, 1, 2, 0, 1, 2, 3, which is basically this one at the index 1, 1. If you can figure out this 2D coordinate for index 5, because you are looking for index 5, if you can figure out this 2D coordinate, which is 1 cross 1, sorry, 1, 1, then you know at 1, 1, there is 13. And then you can compare that, okay, we have 13, we are looking for 23, thereby it will never be on the left half, it will never be on the left half, and then we can do a binary search on the right half. But we don't have this 1D array. Somehow, I have to convert, if I have to write it, I have to convert the 1D coordinate to a 2D coordinate. If I can figure out a formula to do that, I think my job will be done. It's very simple. If you have an index, the formula to convert it is very simple. What you do is, in order to get the row, you basically do index by m, where m is the number of columns. In this case, 5 by 4, which is 1. And you do, in order to get the columns, is index modulo m, which is column equal to 5 modulo 4, again gives you a 1. So you got the row number as 1 and you got the column number as 1. And if you take some other examples, it will work. I'll give you the intuition, don't worry. If I take something like index 10 and try to convert it into a 2D coordinate, it's very simple. What you do is 10 by 4. So that's the column number 2. 10 modulo 4, that's again column number 2. So let's take index equal to 11 and see if it is working or not. 11 by 4, 2. 11 modulo 4, 3. That's 2, 3, which is basically this one and this one, that's 29. And if you look at this, 11 had 29. Yes, it works. It does work.
It works, yeah.
So you might be thinking, divided by m, modulated by m is working fine. But what is the intuition behind it? The intuition is super simple. We have 3 rows, 4 columns. I've taken an example. I've written down the hypothetical 1D coordinates. I've written them down. Let's observe something. The first column is always having multiples of 4. The first column is always having multiples of 4. Why? Because every row has m or 4. Every row has n numbers. Every row has m numbers. Every row has m numbers. That is why, since you start the indexing from 0, the first element is always a multiple of m, which in this case is 4. Thereby, in order to get the row, you divide by m. Because if it's 4, you do 4 by 4 and you get the row number 1. If it's 5, you do 5 by 4 because 4 elements have gone by. 4 elements have gone by. How many 4 have gone by? How many 4 have gone by? That will determine which row number is it. Got it?
Okay.
That's why divided by m. What about column? I know these many m have gone by. So if I'm standing at 9, I'm doing 9 modulate 4, which means 1, 4, 1, 4. That's basically these
0
have gone by. So how much is remaining? That's basically 9 modulo m is the remainder,
1.
which is 0, 1. Because
Damn,
this is
that's really nice.
exactly divisible. What about column? Column is super simple. It's going to be modulated by m, and you know why. Because if the first element is starting from the multiple, in order to get the indexing, which is basically 0, 1, 2, 3, you can observe that this is there's something which is divisible by m. This is something which leaves the remainder 1. This is something which leaves
I'll try to do this then.
the remainder 2, leaves the remainder 3. That is.
Let's try to do this without saying the solution. 17,000. Oh my god. Atlas is giving out perplexity AI for free for a year, it seems, dude. Damn. Really nice, but I think I can't get it because I don't have a Atlas SIM. Don't lose heart. Okay. If you have an Airtel SIM, go get that, dude. Oh, dude, I'm sorry, man. Was I talking for a long time? Yeah, it's um the Airtel is an Airtel Thanks app for Perplexity AI. Okay, so get it if you can, if you have it. I'm using Geo, so I don't have. So yeah, let me start. So yeah, so M is the number of rows and N is the number of columns, and we just have to flatten the 2D array into an n cross m one-dimensional array, and we just put it through the binary search. Okay, array. So yeah, let's try to do this. Hmm. So how do I flatten? Why is the latency high? What latency, dude? You mean my voice to video? No, no, no. It's not the latency. I think it's me reading the messages. I don't know because I'm looking over here. I'm looking over here, so I have to concentrate on either. So I'm not very used to this. So I'm pretty bad at this. I'm trying my level best. Yeah, yeah, I got it. I got it. This is the max. This is the best I can. That is stood for latency. Okay, there is nothing better. Let's do this. So, so n cross m. So n cross m is the total number of uh, rows. So here, so what if we just take here we are taking an array. Okay, so uh, can we just directly take a matrix over here and we just take the last element of less as high, and we just check normally low high and mid-secular low plus high. Everything is the same over here. Nothing to change. Indexes don't have to change. The only thing which has to change is this one. So array of mid, this one has to change. Um, mhm. So what we can do, yeah, we can just directly put the matrix over here. Just matrix. So yeah, here we just say the highest point in the matrix is n cross m. Uh, n cross m, which we have it over here. We just move it. I'll just move it. Oh, mm, mm, yo, yeah, this is good. So yeah, we have the m, we have n, we have the low is 0 for now, and high is n cross m. N cross m is n into m, n into m minus 1. So because we need the last element, which is high. Now we know. Okay, but now we know how to find the mid. Okay, so we have calculated the mid. Now we have to see the element in the mid. So mid, um, so row and column. So to find the row, we are dividing it by what? By m. M is rows, right? And for the columns, we divide mid by, no, so this is modulo n. I have to check this dude before running this. So yeah, so we just copy this again, we just paste this over here. Okay, so let's just see. So low is equal to mid plus 1, so nothing changes over here, nothing changes over here, nothing changes over here. Okay, here matrix. Okay, I'll just directly run the binary search. I'll just, so yeah, we have the binary search. They should technically work directly now. See what error I'm getting. Yo, did it just work? Uh, thank God, it didn't work. Index 1 is out of bounds for length 1. Okay. For what is this case? Yeah, this is the case. So matrix, so we have a 1D matrix. Okay. I got to go now. Thanks. Yeah, yeah, dude. Yeah, thank you for tuning in. Bye bye. Bye bye. Bye bye. Matrix is 1 comma 1 and target is 2, which is not there. So here index 1 is out of bounds in this case. Okay. So I'll just say um, okay. Just a minute, guys. 1 minute. I'll just hit. Mm. So what's happening here? So if matrix, okay, so here, what is mid here? So here low is 1, high is, so low is 0, high is 1. Okay. And mid is, what is mid here? Mid will be, oh, mid will also be, mid will also be 1. Okay, so middle will be 0. So it'll be 0, 0, 1. So middle will be 0 and high will be 1 and low will be 0. So now low is equal to, so now what's the, it's not target is equal to, it's not equal to target because target is 2. We don't even have a 2 here. So what we're taking here is, if matrix of mid 0 by m, 0 by m is 0. Matrix of 0, 0 modulo n. What is 0 modulo n? 0, right? 0 modulo n is 0. What's the error? What's the issue? Sure. Let me fix this myself without asking ChatGPT. Okay. So mid is 0. I'm pretty sure mid is 0. And what is 0 modulo? Oh, modulo 5 is 0. Yeah, 0. So 0 comma 0 is 0. 0 comma 0 is 1. 0 comma 0 is 1 is equal to target. No, it's not equal to target. Then it's working. What's the issue? Mm-hmm. Target is greater than, definitely target is greater. Okay. Target is greater na. Low will be equal to mid, so low is equal to mid plus 1, which is the next element to, so it will be 1 again. So now mid is equal to, sorry, low is equal to 1, mid, high is equal to also 1. Okay, okay, high is also equal to 1. Uh, okay, so now what's the mid here? Again, what's the mid? So low plus high, which is 1 plus 1 by 2 is 1. So low, high, mid, everything is in 1 now. So 1 by m. What is 1 by m? What is m? M is 0. M is 1. M is 1. Okay. M is 1. So 1 by 1 is 1. So matrix of, oh, okay, okay, got it, got it. Okay. So matrix of 1 shouldn't come. So it should be matrix of 0. Okay, okay, got it, got it. I totally got it. Okay, I got the problem at error at least, so I'll just see
Is why
what
modulate
solution he gives.
M
Okay.
will give you the column number. I hope you have got the intuition. Quite simple. So what I have done is basically flatten the 2D into 1D in my head. I'm doing a binary search. So what I will do is I'll write the low to be 0 and the high to be, what's the hypothetical index? Last one. Yes, n cross m minus 1. Because we have n cross m elements in a 2D matrix, so the of mid. By m, we'll do column equal to mid modulated n. That's it. What's the next thing? We'll say matrix of row column. If you are equivalent to the target, we got you. Return true. Else if this is lesser than target, then if it's lesser, it will never be in the low half. So do it on the 1D coordinate, not on the 2D coordinate. Do it on the 1D coordinate. Else we go off what straightforward. Try to submit this and get back into the code, go off one, and that is how it looks like. Quite simple and straightforward. So let's quickly get
What? This is exactly what is what it is, man. And in my code, else if hi man, hi yeah. What? Okay, wait. Oh, this should be M. Okay. I still don't understand why it's M. Oh, okay. I think I got it. Okay. Call and row. Call and row. Yeah, this should work. What's the error again? Same error. Okay. Okay. This matrices M and N always confuse me, dude. Okay, so what happened here is he's taking the row as N and the columns as M. So he's calculating with the columns. So in my case, I took N as columns and I've been calculating with rows, so which is not right. So I should be calculating with the columns. So and I'm doing it right now. This should work. Yep, it works. Really, boys? Really? What the hell? Just like, okay, let's just see what's the next question and try to solve it. Hmm. Implement power x of n which calculates x raised to the power n. No. This is hard. Door mode, Baba, door mode. தெரியல. ஏதோ பூச்சி போயிட்டு இருக்கோம், பறந்துட்டு இருக்கோம், பார்த்துட்டு இருக்கோம். ஸ்ட்ரீம் பண்ணிருக்கேன் பாப்போம். ம், ஃப்ரேம்லாம் வரல. அங்கெல்லாம் ஃப்ரேம் கிடையாது. இங்கெல்லாம் ஃப்ரேம். ஆஃப் பண்ண யாரும் பார்க்கல. ஏய், யாரும் பார்க்கல. யாரும் பார்க்கல பாப்போ. இருக்கும். யாரும் ஓகே பாப்போம் அங்க இருக்கான்னு பார்க்க மாட்டேன். Okay, I'll just try to do it. No, no, not final. Value is equal to the x man directly. Okay. For I int the basic loop. Let's see what happens. What's the result? Let's see what's the value result. Infinite or nan? Okay, got it. I don't know what the fuck should I do.
Hi everyone, this is Trevor here. So today we are going to solve the problem power x comma n. So before starting off with this problem, if you are loving this placement series, please might be given any value of x. It can be an integer, it can be a double. You need to return 2 to the power 10, that is this. And the value of n can be any integer. It cannot exceed the integer. That is what the problem states. So if you are in an interview and you come across this problem, make sure you ask the interviewer, can the value of n be negative? So if it is negative, then you need to take care of some edge cases. At first, you're going to tell him the brute force approach. That is, you'll be looping from 1 to n, and you can keep a variable answer, and every time you loop, you can multiply. Now since the answer is double, do declare answer as double. So this is how you can do if n is positive. But what if the value of n is 2 is double?
Okay.
Double approach. That is, you'll be looping from 1 to n, and you can keep a variable answer, and every time you loop, you can multiply x. Now, since the answer is double, do declare answer as double. So this is how you can do if n is positive. But what if the value of n is a negative value?
What? Oh, so it works.
Then what are you going to do? Now, you know something, if I write x to the power minus n, that basically means 1 by x to the power n. So our brute force actually finds x to the power n. After this, what you just need to do is you need to divide it by 1 by x to the power n. That is nothing but the value of answer. But there still lies an edge case. Now remember, when we started the problem, it was told that n will be a positive integer or it can be a negative integer. It's an integer. So if you carefully observe the range of integers, it is from minus 2147483648 to something about 647. Now, if it is given as negative and you make it as a positive integer, that means if it is given this value and you make it a positive, because you require 1 by x to the power n. So obviously you will make that n as a positive integer. So the moment you change it to a positive integer, it will overflow because absolute value of this negative integer cannot be stored in an integer. Basically, this is the edge case you need to take care. Whenever you're converting, you can take a long or a long, that is your wish. So what is the time complexity of this method? It is actually big O of n because you're looping from 1 to n, and it's a big O of 1 because you are not using any extra space. The interviewer will ask you to optimize.
Let's try. We got the answer. Okay. So n can be negative also. Okay. How do I store this value? So n, okay, n conversion. Okay. So we have to convert it long, long. Let's convert it to long. If negative, then we say return 1 by answer. Return answer. Let's see what error comes. Okay, expected. So just a long. Lossy conversion from long to enter. Let's not convert it. Time limit exceeded. Okay. Ah, you see, 6:47. That's what he said. Damn. What do I do with the lossy conversion? How do I convert it?
Optimize your approach. Assume that whenever you're converting, you can take a long or a long, that is your wish. So what is the time complexity of this method?
Okay, got it. Oh my god. Learning, guys, learning. Chill.
It is actually multiplied with itself. It's to the interviewer will ask you to optimize your approach. Assume that you are given to find 2 to the power
சாப்பிட்றதுக்கு வேணாம்.
10. So you're going to write 2 into 2 to the power 5. Now why can we write this? Because it's 2 to the power 2 and 5. That is what this is. And that apparently means 2 to the power 10. Now at the next step, we can write it as 4 to the power 5. So basically we see something. Initially our x was our 2. So our x got multiplied with itself and our power got divided by 2. That is, it become 5. Now at the next step, you're going to find 4 to the power 5. Now how can you find 4 to the power 5? To find 4 to the power 5, you write 4 into 4 to the power 4. Basically, you take one of the x outside. Now you know it's 4 into 4 to the power 4. So you'll try to find out 4 to the power 4, which basically means 4 into 4 to the power 2. Similar to what we discussed over here, because this is 4 to the power square to the power square. That means 4 to the power 4. So this can be written as 16 to the power square. Now at the next step, we just need to find 16 to the power square, which can be written as 16 into 16 to the power 1. So we have got 256 to the power 1. So you write 256 to the power 1. What you are going to do is, you're going to write 256 into 256 to the power 0. Now you know something, that anything to the power 0 will always be 1. So I can write 256 to the power 1 as 256. Now we were finding 4 to the power 4, which apparently got us as 256. So we can take this 256 and write it over here, which will give us 256 into 4. So 4 to the power 5 can be written as 1024, which will be our ultimate answer for 2 to the power 10. So what did we observe over here? Whenever the power was even, we did multiply the x into x and we divided the n by 2. And whenever the n was, we multiplied the answer with x and we reduced n by 1. And ultimately, whenever our n was 0, we stopped. After the power, our ultimate answer for 2 to the power 10. So what did we observe over here? Whenever the power was even, we did multiply the x into x and we divided the n by 2. And whenever the n was, we multiplied the answer n by 10. So multiplied we observe over here. Whenever the power was even, we did multiply the x into x and we divided the n by 2. And whenever the n was, we multiplied the answer with x and we reduced n by 1. And ultimately, whenever our n was 0, we stopped. So this is when we get our answer. Now you might ask me, what if n is negative? So I have already discussed about this in the brute force approach. You can get back to that brute force approach and see what do I do when n is negative. Time complexity is logarithmic base 2n, because n is getting divided by 2 whenever it is even, and whenever it is odd, it is getting reduced by 1, which apparently makes it an even number at the next step. So let's discuss the Java solution. So initially, I initialize answer as 1.0. Then I will initialize long nn equal to n. Basically, I'm storing a duplicate copy, because in our algorithm, our n will be destroyed. So I check if this is a negative number. In that case, I make it a positive number. That is why I took long, because it might have an overflow. Again, if you didn't understand this overflow thing, you can get back to the brute force approach and understand this overflow stuff. So I keep on iterating unless and until my nn is greater than 0. So if the nn is an odd power, I multiply x into the answer and I reduce nn by 1. Now if this is an even power, then I multiply x with itself and I divide nn by 2. Now after the entire binary exponentiation is complete and nn becomes 0.
Wait. So we take one of the power from the exponential value. We take that and we multiply it once. So now we have an even nn. So if it's even, we do x into x into x. X is equal to x into x, which is x is into x. X into x.
I do a check for the value of n that was given to us. So if this was a negative value, I know the answer will be 1 by answer, so I do it, and after that I will return my answer. So now let's talk about the C++ solution. So I initialize answer as 1.0. After that, I keep a copy of n to nn because in the algorithm, the value of n will get destroyed. So if this is a negative value, I make it as a positive value. So after this, I'll continue my algorithm until nn becomes 0. If nn is a odd power, then our answer gets multiplied with x and our value nn gets reduced by -1. Now if it is an even power, then x gets multiplied with x itself and nn gets divided by 2. So after this looping is complete, I check for the value of n. If it is lesser than 0, that is a negative number, I will return 1 by x to the power n, that is 1 by answer. Return it, and after this I will return my answer. So if you have understood the entire approach and the edge cases, please make sure you like this video, and if you're new to our channel, do not forget to subscribe to it. Along with that, if you want to follow me at Instagram or if you want to join our Telegram,
I totally understood, but I didn't understand exactly. I think
by
so.
one
This one, this part is what I didn't understand.
x. The next can be
Just maybe
write
just go
2
through it.
into 2, 1 to 1, and it's a bigger of 1 because you are not using any extra space. The interviewer will ask you to optimize your approach. Assume that you are given to find 2 to the power 10. So you're going to write 2 into 2 to the power 5. Now why can we write this? Because it's 2 to the power 2 and 5. That is what this is. And that apparently means 2 to the power 10. Now at the next step, we can write it as 4 to the power 5. So basically we see something is what this is, and that apparently means 2 to the power 2, 5. Now why can we write this? Because it's 2 to the power 2 and 5. That is what this is, and that apparently means 2 to the power 10. Now at the next step, we can write it as 4 to the power 5. So basically we see something. Initially our x was 2, so our x got multiplied with itself,
Okay.
and our power got divided by 2, that is it become 5. Now at the next step, you're going to find 4 to the power 5. Now how can you find 4 to the power 5? To find 4 to the power 5, you write 4 into 4 to the power 4. Basically you take one of the x outside. Now you know it's 4 into 4 to the power 4. So you will try to find out 4 to the power 4, which basically means 4 into 4 to the power 2. Similar to what we discussed over here, because this is 4 to the power square to the power square. That means 4 to the power 4. So this can be written as 16 to the power square. Now at the next step, we just need to find 16 to the power square, which can be written as 16 into 16 to the power 1. So we have got 256 to the power 1. So you write 256 to the power 1. What you are going to do is, you're going to write 256 into 256 to the power 0. Now you know something, that anything to the power 0 will always be 1. So I can write 256 to the power 1 as 256. Now we were finding 4 to the power 4, which apparently got us as 256. So we can take this 256 and write it over here, which will give us 256 into 4. So 4 to the power 5 can be written as 1024, which will be our ultimate answer for 2 to the power 10. So what did we observe over here? Whenever the power was even, we did multiply the x into x and we divided the n by 2. And whenever the n was, we multiplied the answer with x and we reduced n by 1. And ultimately, whenever our n was 0, we stopped.
Okay, got it.
So this is when we get our answer. Now you might ask me, what if n is negative? So I have already discussed about this in the brute force approach. You can get back to that brute force approach and see what do I do when n is negative. Time complexity is logarithmic base to n, because n is getting divided by 2 whenever it is even and whenever it is odd.
Let me try this then. Okay. Okay. So we have long n and we don't need this for loop. Um, okay, what I what I have to do. So negative, yeah, this all is not required. So yeah, I'm done eating. Let's focus, 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 focus. So yeah, so while n is not equal to 0, if n mod 2 equal to 0, if it's even, then we say uh, answer is equal to, no, is it answer? Um, it's x is equal to x into x and is equal to, so yeah, so first is it the x, we are multiplying x by itself one time, 2 into 2 is 4, okay, one time. And if it's an odd number, if n is an odd number, we take 1 from n, so n is equal to n minus 1, and we multiply, so we multiply x is equal to,
Odd, it is getting.
so it is equal to answer into x arm. Actually, I have to understand this a bit more deeply. I'll do it later, but I think this is good enough. So if it's even, we do x is equal to, we multiply x by itself, and the power will become by 2. We have x now and n now, and again we do this. So if the n is, for example, 5, uh, we do answer. Why we do answer is the question here actually. Wait, wait.
What if
Let me
0,
understand it
whenever
more.
the x with 4 to the power 5 cancel for 2, we did multiply the x into x
Okay.
and we divided the n by 2. And
Okay.
whenever the n was, we multiplied the answer with x and we reduced.
Why? 4 is the answer. 4 into answer 4 is equal to So answer is equal to 4 into x.
Reduced n by
Still don't understand, but
by 1. And ultimately, whenever our n was 0, we stopped. So this is when we get our answer. Now you might ask me, what if n is negative? So I have already discussed about this in the duplicate.
greater than 0. Yeah, this is almost everything is same here. What is the problem? Wrong answer. Okay. Two minus 2, which is 1 by 2 power minus 2. So 1 by 2 power 2. So 1 by 4. 1 by 4 is 0.25. I'm getting. What's the error here? It is negative. We're not even using n. Okay. So answer also is double. Okay. Everything is double. Mm-hmm. Mm-hmm. Yeah, zero. Answer is double already. ಅದೆಲ್ಲ ಅಂತ ಆಗಲ್ಲ. I convert it. It's also not needed. Seems like oh. And so we convert it into positive. So while it's greater than zero, we do all this uh, calculations. So yeah, if you use n, okay. Yo, what? No, no, I'm doing Java. I know Python, but I'm doing in Java. I'm learning Java, so I think I thought of doing in Java instead of doing in Python because Java is quite a bit statically typed, so it's better to learn Java than to learn Python. That's why I'm learning Java. Hmm. Not getting the answer though. What's the issue? What would be the issue here? You're a beginner. What is your goal? Why are you typing two times? What's your goal? What's your goal? Like what job are you planning to go? What job are you trying for? Is it like data science? Uh, oh, I'm a beginner. Placement in big companies, dude. Um, I think Java should be good. Java should be better because yeah. Java should be good, really good. Because from Java you can easily learn Python also easily. So I think Java could be very good for a beginner to learn instead of some other languages. DSA, yeah, DSA with Java. Python is kind of easy, dude. So I would prefer not to learn Python like explicitly, because Python is very easy that you can easily get into the language. You want your resource for Java learning or DSA? To learn DSA, yeah, then you can better what to do, dude. I think it's better you use this striver. See, I'm using this striver. I'll just copy this. So this I'm learning DSA with this only. Uh, this guy will have resources for every different problem, including YouTube links. Uh, Instead of that link, you can, if you go to Striver's A to Z sheet, you can learn from the basics. Copy this. See, this the second link what I pasted is for fully completely beginners. Okay, you can learn everything from complete scratch. Okay, he'll teach you everything one by one, even with the see time complexity is very important. So learn this. Okay, yeah, that's it. Nothing much. If you Outlast, yeah, done. It was done in that day itself, dude. I completed it in one stretch. Which college? I'm done college, dude. I was doing my BTech in Dr. MGR University, Chennai. Yes, man. I don't know. Uh, what you aiming on doing today? What is TDY? TDY is today. I don't know, dude. I think it's today, but if you're asking me what I'm gonna do for today, I don't know actually. Hmm. Yeah, actually, already I did these two questions. Oh, I got NIT Bhopal, dude. Very good, awesome, man. I'm thinking of doing one more question. I'm gonna end it, dude. My mind is not good for some reason. You know what? I got no motivation whatsoever. Oh, mechanical, dude. Then it's really good. You do this for if you do DSA for fun, you can get a lot of. Hmm? Can you guide me, dude? Uh, what do you mean guide? I don't understand what exactly guide means. But yeah, I can help you from whatever I know. But I'm not really good at things like you might expect. But yeah, I can help you. Okay, good info, much appreciated. Given an array nums of size n, return a majority element. Then the majority element is the element that appears more than n by 2 times. You may assume that majority element always exists in the array. Okay, always exists. Okay. So basic counting of elements, I can do that. To learn any language for placement, yeah, dude, Java is the best, I think. Even mechanical, I think. You know, in mechanical, if you go for computer science mechanical, okay. Um, if you go for a computer science related mechanical field, you might wanna like do real-time systems. Real-time systems like which works on like cars, engines, bikes. The small systems which work, which we have. The displays, the what to say, the braking system. All these are connected, right? So these all comes under like real-time system, which also need mechanics for better work. So if you want to go for that field, you should definitely learn Java, because Java is really used in that fields. Who do I contact you? You want my contact? You can reach me out on Instagram, I think. Time is okay. Reach me out on Insta or LinkedIn. Okay. Just text me on Insta. I'll send you my LinkedIn, because I don't think my you would get my LinkedIn if you search for it. But anyways, I'll give it. Just try to. Yeah, this is the time is love is my Insta ID. Okay. Do you need a hint for this question? Yeah, man. I'll try to do the basic count solution, which I always do. Okay. Mm, let's do count dictionary. I mean count hash. And so we'll do. Hash is not permitted. Who said it's not permitted? Okay, okay. O of one space. Okay, okay. Got it, got it, got it. Yeah, 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 yeah. Okay, got it, man. Um, what would be a linear time solution? We can like, should we sort it? Like sort it, and we can find the maximum occurring elements. No? If we sort it, yeah. Sort the array that's element. Yeah. So sorting is the right way. Then let's do it. Okay, nums relates directly arrays dot sort nums. Hmm? SGYT YESSJEE. So should we for loop it? I is equal to 0, I lesser than n by 2. Let's just say n by 2. No, n by 2 is enough, I think. um, I plus plus. Um, so oh no, n by 2 one should not come. It's n minus n the n only. Max count. Let's say max count. Okay, got it. So I have to store the current element somewhere, the previous element somewhere. I mean, only store the count. Okay, if I is equal to I plus one. No, this is correct. No. Yeah. Okay. So if you're gonna do that, then I'll just say equal to. Okay, this should work. If this is true, oh, okay. Let's just say one. Let's do it from one to. Yeah, I think your method will be right. Better. So if the previous element is the same as the first element, then we let's say count plus plus. Yeah. Yeah, you're saying it, I'm doing it literally like the same time. Else, let's just say count equal to one again. Um, and we just store. If you're saying count, just say max count, no? Dude, we'll just say max count like the digit itself, no? Max count, say the number itself here. So max element, we'll say max element. Yeah, equal to yeah, max count not needed. I think element is needed. No, we need the element out. That's what I'm doing. So whatever has the highest count, we had to store it as max element, right? Hmm? Write another if after the else. After the else or inside the else? I think inside, no? If count is greater than max. Oh, okay. So you're saying you know we don't even need this. If count is greater than n by 2, return nums of I. But we are changing the count to 1 again, right? So that won't work now. Whatever you're saying, so you're saying over here we put an if. Okay, like you're saying over here if count is greater than n by 2. Okay, you're saying me to return nums of I. Okay, I understood this, but this won't work now because count is uh, count is changed to 1 again. So what if the sorting sorted array has like one like a lot of ones and twos are less, and the for loop will go to the 2. Okay, try run on first test case. Okay. What? Oh, I will. This is okay. I know this will work. Yeah, see, expect I output is -1. Okay. Um, so expected is 1. See, so what's happening here is, see what's happening here is we are taking. Oh, okay, okay. So this should be 0. No, the thing is, array of n minus 1 after the loop. What do you mean? Return array of, okay. Oh, gee, okay, nums of, my bad. Dude, wait. Oh, it's accepted. Damn, but I don't know what's happening to it. Listen. Let me understand this. Okay. So yeah. So here, try run using pen and paper. Yeah, I'll do it in my just like mind. Let's see how much fast we can do. Okay. Hmm? So this I understood. Okay. So we are checking the previous element. Okay. If the previous element is same as the current element, we count plus plus. Else count is equal to plus count is equal to 1. If it'll be reset. Okay. So but the thing is, if else, okay. So one more if. Oh, okay, right. I think I got it. I think I totally understood. Is this the most optimal solution? I think yeah. N no of of one space. Um, yeah. This is time complexity of O of n, and the time complexity space complexity will be, yeah, yeah. I think it's O of one only. Okay. Should we check the YouTube?
To optimize it, this is when you'll be giving the better solution. So what will be the better solution? The post solution will look like hashing. That is what I will be doing. So
Okay,
I'll
hashing is what
everything is
I
taking
thought in the
n.
first.
So
Okay.
what is the total time you
Oh,
have
the
to mark
space
it up?
complexity.
No.
Okay.
The interviewer will be grilling you on thought process and intuition. If you mug up the algorithm and you just present it line by line, you'll understand that you have mugged up the algorithm. So please make sure you understand the thought process. I'll be sharing the thought process two variables, element, things. So the moment you give this hashing solution to the interviewer, he'll be like, map. And what is the space complexity? Big of n, because you are storing all the elements in a. So thereby, at the worst case, in case of worst case, what is it? That you haven't taken any array. And we, again, what's
What is
the
this? Morse voting
thinking, but
algorithm. Okay.
algorithm. And that will be using something as the Morse voting algorithm.
Okay.
Now, sitting in an interview, you cannot invent this algorithm. So you have to know this algorithm beforehand. So you might be thinking, but does that mean we have to mug it up? No. The interviewer will be grilling you on this algorithm. Two variables, element and count. Initially count is 0. And you can say initially the element is not initialized. And we start iterating. So whenever we are iterating and we are at the first element or wherever, if the count is 0, that means we haven't taken
Yeah.
any.
Of course, man. Whatever tip you wanna give me. Not gonna note it down. Just I just just took my book for the dry run part. Whatever you said. Tell me. These algorithms don't come up in interviews. Yeah. So you're saying you don't want me to say this?
Array. Please hear this out properly. We still haven't taken any array. So you will be like, okay, I will take 7 and I'll increase the count to 1. So what I did was I said, I will consider this 7 to be my answer. I'm just taking an hypothetical assumption that 7 is my
There is no use of doing that. But learning the like understanding them is also not worth it. I mean,
answer and the count is 1. And now let's start moving. We again move to 7. Like 7. Now this occurs twice. 5. No, it is not 7. So you reduce the count.
it's understanding
Remember,
them
this
also not
count
worth
is
it.
not storing how many times 7 appears. It doesn't. It has some other significance, which I'll say. Next, again 7.
See,
In
dude, like the thing is, we what we did, we sorted the array first, no? So sorting takes time, right? But technically we shouldn't be sorting. We should just directly do the O of n time complexity algorithm, no? But if we sort, then we do the sorting complexity. The sorting complexity also will get added. That's what I'm thinking. So,
increase. Next, again 5.
so if
Decrease.
the interviewer asks, what would you, why, how would you do it without sorting? What would you say? What would you say?
Next, 1. Decrease. So whenever you find 7, you increase because 7 was your element. Whenever you find anything apart from 7, you decrease. Now you are reaching
I don't
screen.
understand.
And also, I'll increase still has 0. That means items and count. Initially count is 0. And you can say initially the element is not initialized. And we start iterating. So whenever we are iterating and we are at the first element or wherever, if the count is 0, that means we haven't taken any array. Please hear this out properly. We still haven't taken any array. So you will be like, okay, I will take 7 and I'll increase the count to 1. So what I did was I said, I will consider this 7 to be my answer. I'm just taking an hypothetical assumption that 7 is my answer and the count is 1. And now let's start moving. We again move to 7. Like 7. Now this occurs twice. 5. No, it is not 7. So you reduce the count. Remember, this count is not storing how many times 7 appears. It doesn't. It has some other significance, which I'll say. Next, again 7. Increase. Next, again 5. Decrease. Next, 1. Decrease. So whenever you find 7,
because these algorithms, if you know, you know, and if you don't, then it won't come up to you directly because they are these are invented by computer scientists. Okay. Yeah, dude. Like think about this. Okay. Like this is my understanding of why we need to understand our algorithms. So this is a easy problem. Okay. So what if they ask a hard problem, but the base of the hard problem is this small algorithm. So if this might be a not very important algorithm, but what if you take a hard question and in future, like if I get a hard question, and this comes as a base, uh, what to say, processing. Let's say processing. Okay, we take the input, we process the input with this algorithm, then we move on to the other algorithm. Like hard problems, right? It will have like two or three algorithms together combined. Yeah, but on these questions, if you buy hard, then only you would know it. Oh, you mean, okay, the algorithm you have to by heart. Okay, okay, okay. You mean, yeah, yeah, I definitely understand because algorithms, I can't, no way you can like, uh, remember it without by hearting, right? Yeah, that's true, man. That's true. But isn't this algorithm used like commonly, like multiple times? It's like binary search, for example. Binary search, if you, I do computer program, I know these are not of any use. Oh, okay. So you don't want me
You
to do
increase
this?
because 7 was your element.
So just skip it then. Hmm? And start. Yeah, yeah. Binary search. I know binary search. Actually. So what about this? N by three times. What is this? Oh. Yeah. Time complexity is O of n only do it, but we didn't consider the sorting part. No. Sorting part is also important, right? You, we totally forgot. See, we literally sorted. The sorting algorithm alone will be this much big, but we just used a direct sort function. But I'm just saying. Okay, fine, fine. But here they're asking multiple. So find all elements that appear more than n by 3 times. Okay. With sorting, it is O of n plus log n. Yeah, which is about, yeah, yeah. That is what, yeah. Actually, I was learning about it, and he also said the same thing. It is about, it's like very close to O of n, but it's not O of n. Yeah, yeah, understood. Yeah, this is good enough. Yeah, you're saying this is good enough, right? Yeah, understood. Totally understand. Yeah, instead of concentrating deeply on one problem, we can cover a lot of problems and in that particular time which we are investing on one problem. Yeah, and no online judge can reject you if you wrote extra. Okay, okay, got it, man. Yeah, yeah, I understood. Okay, how would you approach this one? So they're asking like multiple. Could you solve the problem in linear time and in O of one space? So they've given a list of integers 3 to 3 and they're asking output also as list. Just appeared more than same code copy paste. No. Okay, okay. Killing the changes. So yeah, return should be the list. Okay, that I know. This list I know. But the count, everything will change, no? Here instead of return, we have to add a list. I think. Yeah. I think I understood. So we have to make a list. I think, right? What is a list? Okay. Here instead of returning, just add it to the list. List dot add. Dude, I forgot. Just a minute. Add. Okay. You mean this one? And by 3. That's it. Mhm. I should technically add one. Oh, okay. Here I think we have to add list a dot add thumbs up. No. If you add here, it's not right. So I think here, I think one more if. Wait. Yeah, man. We are starting from first index. Yeah, that's what I'm thinking. So if we change z to 0 and we just check this I with the next element I plus 1, this is also correct, I think. No? But this should be only till n minus 1. See, but if this is the case, um, it would give an index out of range. Right I from 0 only, yeah. Yeah, dude. Yeah, that's what I'm doing. But see, the thing is, I will be 0. But if the index size is also like I lesser than 1, okay. But if I is lesser than 1, it won't work. It'll throw an index out of range. In first if, right? Yeah. What? We have to put one more or condition, like and condition. And I original condition. What is original condition? You mean the count is greater than n by 3? What is the original condition there? Okay. This will throw an error, dude. What are you suggesting? What are you suggesting? See, if we do this, it will definitely throw an error. That it'll go 0 minus 1 and just minus 1, and minus 1 is not present in the array, so it will say nums of I minus 1 is not in the array, index out of range. Unless we check it, unless we have another condition which checks if I is not equal to 0. If it's equal to 0, we can handle it later. That's something we can do. This chat is not going. Oh, you're typing the code and it's not working. Now just tell me what to do. I'll do it. Like tell me the. I'll go. I'll try to implement it myself. Like what is something you wanna do? Just tell me that. I'll try to implement that over here. Right? Or condition. Yeah, that's what. Or or what? But or no, or won't come. Pretty sure or won't come. But tell me. I'll try it. Or what you wanna check? Yeah, that's what, dude. Or I is equal to 0. What? That is not needed, man. Yeah, here I minus 1 is greater than or equal to 0. Yeah, this is okay. You can just say I is greater than 0. That's more than enough. Copy paste inside your if. Yeah, that's what is there already, I think. So yeah, so what's happening? We are not checking 0. So we are skipping 0. We are starting from, yeah. Your equation is only there, dude, inside. So we are skipping 0, okay? And from 1 again what we are doing, we are starting from 1, and we are checking if 1 and the next element is equal, and again next element till the last element, okay? To write full equation. What do you mean the I is equal to 0? Oh, okay. Got it. Okay. So what we are trying to do here, if I is equal to 0. Yeah. Got it. Okay. Yeah, I was thinking why we need this. What? Dude, I'm clueless. If I, if you're saying if I should be greater than 0, but if I is equal to 0 also, we count plus plus. Okay. Okay. I think I understood somewhat. I'm just doing it simply. Okay. Just wanna see what's happening. Yo, we got it, man. I think it's. I don't know. I think it's. Okay. Almost working. Almost. Okay. என்னது இப்போ பார்த்துட்டு வரணுமா? பார்த்துட்டு வரணுமா? பார்த்துட்டு பார்த்துட்டு வர முடியும். நான் திருப்பி அங்கே உட்கார முடியாது போயிட்டனால. ஆஹா. ம். Okay, sorry. Sorry guys. Sorry dude. My bad. Um. Okay. Okay. Mm-mm. Look at this guy. Look at this guy. Look at this guy, dude. Okay, it's really hard to explain through chat. Yeah, dude. Yeah, I totally understand. Um, yeah, this part I understood. Okay, so if it's zero, then we count plus plus, and else again we initialize count is equal to zero. Okay, so if count is greater than n by 3, day. Che. Okay. Chakka. Che. Bah 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 bah. Che. Okay. Bah. Che. Okay. Sorry. Okay, dude. What do you do? Is there a way? Chakka. Look at this guy. Look at this guy. Judging me. There is a way, but long way. What would be the way? Hard to explain through chat. Okay. But okay, tell me what. Why did we initialize the count as one in the last question? Because we're already on. Because we're already on the uh, on the element while looping. Is that the reason? Hmm? Dry run. Oh, you mean the textbook? Okay. So I mean writing. Okay. You want me to dry run the last question or this question? You're so gig lock in. Yeah. What is n by 3? Okay, so first is 3, n by 3 is 1. So if it's greater than this, it's not greater than this, so we don't add this here. Okay, just don't add this. Yeah, that's true. That's correct. Okay, so the next time we say we check 1 and nums of I is equal to nums of I minus 1. டேய் அடி வாங்குவடா அடி வாங்க ஓகேவா ஆமா இப்பதான் அடி வாங்கினா செம அடி செம்ம அடி வாங்கினா அதான் சரி ஓகே போட்டேன் என்கிட்ட இப்போ வெளில போகணுமா வெளில போகணுமா உனக்கு வெளில போகணுமா எங்கே போகணும் உனக்கு ஆ ஃபுல் வெளில போகணும் ஃபுல் எனர்ஜி போடுறேன் இப்போ பக்கத்தில் மெதுவாக ஸ்லைட் ஆகிறான் பாரு எஸ் not true, so count is equal to, again we have to put 0. Okay, 0. Oh no, nothing is 1 here. சக்கரு அடி நான் அடிக்க வைக்கிறேன் இரு இந்தா அடி ஃபுல்லாக அடிக்க வைக்க போகிறேன் அதான் அடிக்க போகிறான் அவன் எழுந்துட்டான் அவன் நீ எடுத்து வச்சுக்கோ வேணா so it's 2 3 3 first element ஒரு மூடு போ 2 3 3 first element is count 1 again now 1 now again it's 1 again now it's 2 I was gonna add 3 so expected 3 should be, yeah dude I think I get it. Count should be 1 only now here. If it's 1 then only it'll work. See, okay I think I almost see this is correct. So this 2 3 has to go, 3 is right. Here also 1 is enough. 2 should not be here. Why is 2 here? Hmm. Why is 2 here, dude? See, 2 will be initialized first. 2 will be the first element of the array. Okay, 2 is the first element of the array, and the count will be 1. Um, okay, because the count already is 1. Okay, okay. So let's if so this 0 should be, this won't be 100% true for all the cases. I think so. Yeah. If it's 2 comma 2, this doesn't work because 2 okay is playing, dude. Chuck is playing. Okay, so it doesn't work because the first element is 2 and the count is 0 now, and the second element is also 2, so the count will be only 1. Okay, so count will all 0. Now the second element, we check the second element. Now we take it, we put 1 now. NASG mass பண்றியே. What? NASG mass பண்றியேவா? This rock. Oh, Giri. Nice, bro. How are you, bro? Life எப்படி bro போகுது? How's life? வேலை கிடைக்காம கஷ்டப்பட்டுட்டு இருக்கான் bro. Nice work. Keep grinding. ஏதோ போகுது. Super bro. உங்க significant otherலாம் எப்படி இருக்காங்க? All good? Super bro. டாக்டர் எப்படி? என்ன விசில இருக்க? என்ன புரியல எனக்கு. அப்படின்னா என்ன வாய்ஸ் சேட்டில் இருக்கேன் நானா? இதுல இல்லை ப்ரோ. நான் இது தனியாக தான் இருக்கேன். சும்மா பேசினா வேலை பண்ண மாட்டேன்னு சொல்லிட்டு பேசல யார்கிட்டயும். ஃபோக்கஸ்டா இது ப்ரோ. 10 மினிட்ஸில் வரேன். ஓகேவா? இதை இந்த கொஷினை முடிச்சுட்டு வரேன். ஏன் 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 என்னோட சர்வர் வாங்க ப்ரோ. ஓகேவா? என் சர்வரில் எவ்ரி ஒன் சேனல். ஓகேவா? நான் வரேன், இதை முடிச்சுட்டு வரேன். ஹோல்ட் ஆன். இந்த கொஷின் மட்டும். ஓகே, ஸோ 2,2. So its count is only 1. Next it's just 1 now. Is it not added? Okay. So if it already exists in the list, we don't need to add it. So we can add the condition now. So list A. Index -1 is out of bounds. Okay. Oh, shit. Mudge. Mudge. Okay. Mm, so, if it's already there, wheatless sleeping bro. My nephews. Okay. என்னடா இது? Uh, Dude, I'm gonna do it. Sure. Counting logic, you are incrementing. Make two other lists unique and amount. Okay. You are incrementing count for every matching number, including overlapping groups. So duplicates may be added. Yeah, that's the issue right now. You're not resetting count properly for each new group of numbers. No check of next check for duplicates in the output. Yeah, that's exactly what I was fixing the code using sorting approach. Yeah, so we sorted and we have a list. If it increase the if it is increase the value in the same place in the amount list. If it is increase the value in the same place in the amount list. Oh, okay. Okay, got it. You're telling me to have a list separately to count the number, and from the counted list, you were asking me to then do a loop, then to put it in the new final list. That's what you're saying. Yeah, I get it. I totally get it. Check the amount of list. Yeah. Got it, man. Yeah, that is correct. Yeah, that will be better, I think. No, I'm trying to do it with the space complexity of O of 1. What you're saying is O of n. That is the issue. So in this, no, yeah. Dude, I totally understood what you already said, dude. What you're saying is to create an array, count array, and we count all the elements, okay? And from the counted elements, we have the count elements array, and from the count elements array, we again do a loop where we check each element. So if this element is greater than n by 3, then we add it in the final array. This element, yeah, that's what I totally understood. So, but space complexity will be O of n in that case, because we don't know how many elements are present in that. So we will be scaling the space based on how many elements present in the given array. So that's O of n. So O of 1 is what I'm expecting. That's why I'm doing this. So in this case, we have only specific spaces, right? Like count is one, uh, like one list, one final list. So it's all almost O of 1. So that's why I'm trying this out. So what's happening here? So I is equal to, so here also he's starting from I is equal to 1. So count. Hello, boy. Is there any problem with TSA? No, no problem, man. I I did it with C++ only. I know C++ also. I started TSA with C++ only. Okay, and I then later migrated to Java. C++ is actually much better to learn than Java, because in Java you have to like see. For example, I'm showing you, right. For example, see this. Just to create a list, okay, you need to list integer. You have to do this in C++ also, but you don't have to like mention these things. This new array list. This is like creating an object from a class, already existing class. So these methods have to be followed in Java, which is pretty hard for beginners, I would say. But C++ is much more easier than Java in this case. So I think C++ also is much better. Why I'm suggesting Java is that Java is used widely now in like industries. So if you have a good base in Java, you can easily like you know learn other languages quickly. That's why I was suggesting that, but it's your wish at the end of the day. But I would suggest C++ and Java both. But Python, I don't know. I won't suggest Python, dude. Python is very beginner language. You would learn Python in like maybe a week if you know Java and C++ or C++. Like entire Python fully, completely. Mm, okay. Else if count is greater than, what should I do? That's what I meant. That's what, man. You could go C++ or you could go Java. Java would be better because it is used in industries. C++ would be better if you are a beginner and if you want to learn coding from scratch. Then C++ would be better. But Java is better because it's used widely. So you choose what you want, because it's not there won't be a lot of difference between languages. But Java is the base for every language after Java. So think about it and decide. Yeah, and also for competitive programming, no, C++ is kind of good. You have to remember the import command is there, right, for all libraries. You have to import all the libraries before you actually do something in the competitive programming. In Java, it's pretty easy, java.util.star, okay. But in C++, I think it's bits bit slash std.io something. See, even I don't know. Wait, let me just check. C++ add all libraries. Hmm. Yeah, this one. So bit slash std c++.h. Oh, I have messaged you. Okay, dude. I'll check it. Okay, so yeah, let me do just one question, dude. I'll just complete and I'll go. It's very hard for me to just. Ah, shit. Yeah, so count is greater than the result at add nouns I and count is equal to 1. So he's just checking before he is resetting. Okay. So this is what I suggested. Okay, first. Okay, got it. And finally, we check the Final check for the last group. Count is greater than 3. Uh, Suggest some good laptop under 60K. What are you gonna do, dude? Like, tell me what exactly you're gonna do. Like, list all the things you wanna do in the PC. If you play games, tell me what games you play. If you don't play games, then tell me what you do exactly. Like, what do you want? Battery life, uh, like good display, everything. There are a lot of factors for considering a laptop. You want a good display, a good keyboard, a good build quality, coding and editing, etc. So you want editing. Okay. So tell me if you want to use it as a laptop or a desktop. You understand what I mean? Because laptops are generally used as a laptop which is not connected to the uh, power. Okay. If you're not use your laptop as a desktop, you should always be connected to the power. Okay. What kind of editing you mean? Tell me what kind of editing you wanna do. Hmm? Tell me what kind of editing you wanna do, like video, how much video editing, like graphics, like you wanna do 3D rendering or just video editing. A lot of stuff is there. Just tell me that. No, just YouTube video and Premiere Pro. Oh, Premiere Pro. Okay. Uh, 60K. What is there in 60K? 60K. Mm-hmm. Let me just check, man. 1 minute. Hold on. 3. Then just add list a dot add nums of n minus 1. No. Yeah, just check my stream, no? Okay. Uh, Top under 60K is what you would search for. Okay. Oh, 2050. Okay. Oh, no graphics. Okay. You wanna try this? It's just tough. This one. Are you like looking at the stream? This is good actually, but this is like a kind of gaming. Dude, price definitely will be 65 or 70. What would like that would be the price. It's very hard for you to get a good one like in the price what you are suggesting. So it's just 60K. This is good actually. This is also good, really, really, really good. Mm? Because it's 13th gen. Yeah, it's still nice, but M1 is like really outdated, dude. Like it's very old. How many years it has been since M1 came? I think 4 or 5 years. That's what. 2020. See, 5 years, dude. Yeah, gaming don't buy. Yeah, see, this one is good. See, a creator. This is creator. So try to get this one. Oh, this is 2050. No, 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 no. Wait, wait, wait. Don't get 2050. Yeah, this one. 64,000. See, this is 3050. You can't do like a very good editing, but you can do decent work. And also you get all the office home and 365 everything over here. You work in any company? No, I don't work. I'm unemployed. I'm trying to get a job, dude. I'm not working currently. Just a minute. Hello. Yeah, hello. Yeah, dude. So try to get this one. See, this is very slim also, no? See, it's kind of slim. Yeah, it's very slim. Yeah, I've completed my BTech. It's been like 2 months, I think. 2 months it has been. Yeah, 2 months. No, just 1 month, dude. May I completed. It's been a month since I completed. And yeah, dude. Yeah, try this, dude. Uh, okay, try this one. Hmm. This is like 65,000, and I feel like this is really good because 3050 and 13th gen. So I think battery life will also be kind of decent. It won't be like crazy, but it should be good. Yeah, MacBook is really good, man. Like trust me, MacBook is really good. Even I thought, yeah, that is good. You can extend 20 more thousand. Yeah, that's really good. MacBook is really good for for student and for coding, for typing. Keyboard is really nice in MacBook. Try to get student discount or something. If you get a discount, like good discount, then MacBook is definitely good. I mean, the typing experience is really good in MacBook. Like one of the best, easily. The keyboard. I love keyboards, dude. Look at this. I bought a keyboard. I bought a separate keyboard now because of my love for keyboards. I mean, but MacBook keyboard is really good for the laptop we get. Yeah, okay, dude. Yeah, try to get this one 64,000 or try to get student discount from Apple. Okay, if you get it, dude, it's really good. Okay, if you go for 70K, then it's there are like lot more better laptops out there. But based on your budget, yeah, I think we gotta choose. Oh my God, it's 94,000. Holy shit. This is a bit too high. I think you try M3 or something. Check for the prices, okay? Don't buy very soon. Take your time, think about it, see if it's really worth it, okay? If you really want to spend the money on it, okay, then you get it. Don't rush. Never rush on a laptop purchase or a desktop purchase, dude. I've had very bad experiences in the past. Okay, just take your time. Yeah, okay. Okay, guys, I think I'll stop it. Yeah, Siddharth. Siddharth, yeah, man. I'll definitely do it tomorrow, okay? Yeah, dude. Take care, guys. I don't wanna overdo it. I wanna stay consistent as possible. And tomorrow I'll be here no matter what. I don't know the timing, but I'll be here. Okay. Okay, guys. Thank you, man. Thank you, guys. Thank you, Pranjal, and thank you, Siddharth. You tried your level best, dude. Thank you. Let's see tomorrow. Let's do at least five or six questions tomorrow. Okay. I'll try to do 5 questions. Yeah, dude. Yeah, guys. Take care. Take care. Bye bye. I'm talking like there are like 100 people here, but only 3 people. Like, fine. It's fine. Okay, guys. Bye bye. Yeah. Bye, guys. Bye. Peace. Peace. This is for thumbnail purpose. Okay. Don't mind it.